Hi, welcome to our notes that are going to talk about the measures of central tendency. So this may be a review for some of you, which is a good thing. In our day-to-day activities, we'll deal with many problems that involve the related items of numerical information called data. Statistics is the study of sets of such numerical data. What I want to point out very quickly is statistics is pretty much its own subject. A lot of times we see statistics in math, like right now, but you will also see statistics in science and social studies just as much, if not more, than mathematics to study all of the numerical data. When we gather numerical data, besides displaying it, we often want to know a single number that is representative of the data as a whole. We call these types of numbers measures of central tendency. The two most common measures of central tendency are mean and median. Okay, and that's what we're going to practice with today. A survey, so starting with example number 1, a survey was taken amongst 12 people on the number of passwords they currently have to remember. The results in ascending order are shown below. We're going to state the median number of passwords and the mean number of passwords to the nearest tenth. So why don't we go ahead and start with median. Median, let's remember, is our middle number. So probably the easiest way with median, make sure your numbers are lined up in order, okay, which in this case they are. It tells me in the story problem that we have 12 elements in this. So my halfway point is going to be in between 6 and 7. So I'm just going to count. So 1, 2, 3, 4, 5, 6. Okay, and if I count on the other side, 1, 2, 3, 4, 5, 6, I have found my middle point. So, you know, we can just take a look at 2 and 3, and the middle of 2 and 3 is 2.5, or we can remember that when we have an even set of data, we're going to take the two middle numbers, add them together, divide by 2, and we get 2.5. So either way you do it is fine. The next thing we're going to do is calculate the mean. The mean is to add up all the numbers and then divide by how many numbers there are. Okay, so what we're going to do is use some sort of calculator to do this. And so when I add this up, 0 plus 1 plus 1 plus 1 plus 2 plus 2 plus 3 occurs 4 times. And we get a total of 29. So we're going to write down 29 divided by 12. So you do need to show this little bit of work. And then we'll show 29 divided by 12, rounding to the nearest tenth. This will be about 2 4/10. Okay. And that's it for problem number 1. Problem number 2, we have students in Mr. Bishop's algebra class. We're trying to determine if people sped or if people speed along a certain section of a roadway. They collected speeds of 20 vehicles, that's important, as displayed in the table below. Okay, so if I take a look at this data is, I don't know, I would say this is more like a frequency table where, you know, it's not all listed out like we had it before. So what I mean by that is we have one car at 29, but we have 2 cars at 33. Okay, so that's what that would look like. We have 4 cars at 34 miles per hour. And this is going to be important, 1, 2, 3, 4, when we are trying to calculate our median and our mean, okay, that we are using all of this, all of these numbers. So I recommend just writing it out as such. The other option, because again we are finding the mean and the median, is just to count to half of 20. So half of 20 is 10. So if I count over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, this is 10. So I'm going to divide it right here. I should have 10 on my second half. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I do. So my median, I would add them together and divide by 2, but they happen to be the same number. So I can just write down that I have 35 miles per hour. for my mean, again, we're going to take all of this and add it up. Okay, there's lots of ways that you can do this with your calculator. One way is 29 plus 33 times 2. Notice that I am including the inclusion symbols, okay, the parentheses. If you don't, your calculator, it'll be user error where the calculator doesn't know order of operations. You have to put it in there for it. Okay, so doing it this way, just kind of 35 times 5, right, rather than writing plus 35 5 times, I think it makes entering all of this information much quicker. Oops. And the key thing is also making sure you enter it in accurately. And so 722, so when I'm writing my mean, it's going to be 722. Again, I need to see this work because this way I will know where you made your mistake. Was it with the addition or was it with the dividing? And if I take this value and divide by 20, since we have 20 vehicles, it's 36 1/10. And we can go ahead and box that in. Now, the next part of these notes, and you'll start seeing this more and more as you move along your career in high school statistics, is analyzing and interpreting this data. Okay, so the speed limit along this part of the highway is 35 miles per hour. Based on your results from Part A, is it fair to make the conclusion that the average driver does speed on this roadway? So again, we're going to interpret this information. The way that we're going to look at this is I notice that my mean is greater than 35 miles per hour, but my median is exactly 35 miles per hour. And so which data point would I use to answer this question? Well, when I look at my data over here, I see that I have one driver at 54 miles per hour. Now, this is considered an outlier. Okay, and so with this outlier, it rose our average speed, okay, our mean speed. The other thing, too, to think about is, remember how our median was 35? When I count up how many drivers were at 35 or under, okay, so 1 plus 2 is 3, plus 4 is 7, plus 5 is 12, well, that's 12 drivers drove at or below the speed limit. That's more than half. Okay, so again, what I just did is I analyzed my data, and now I'm going to interpret it. I'm going to go ahead and state, no, even though the mean speed is 36 miles per hour, the median was at 35 miles per hour. And I'm just rounding here. Again, the median is right at 35 miles per hour, is at the speed limit. So of the 20 drivers, "12 drove at or below the speed limit." The mean is above 35 miles per hour, and this is because of the outlier. Okay, now pause the video if you still need to write this down, but I can't stress enough that when you are answering these questions, you are in an honors math class. This is expected of you to be able to accurately analyze and interpret your data, okay? Anything less, you will not be getting full credit. Okay, let's flip this over. Let's talk about some more situations. So when conducting a statistical study, it is not always possible to obtain information about every person or situation to which the study applies. Unlike a census in which every person is counted, some studies use only a sample or portion of the items being investigated. Whenever a sample is taken, it is vital that it be fair. Okay? In other words, the sample reflects the overall population. Okay? So that's what we're going to talk about here for number 3. To determine which television programs are the most popular in a large city, a poll is conducted by selecting a sample of people at random and interviewing them. Outside which of the following locations would the interviewer be most likely to find a fair sample? Okay. Remember, it would reflect the overall population. Explain your choice and why the others are inappropriate. Baseball stadium, concert hall, grocery store, comedy club, okay? Which television program would be the most popular? Okay? So, each of these locations would have some sort of bias. Okay, so which one would have the least amount of bias? So let's go ahead and state probably the grocery store. Would have the least amount of bias. Okay, so most likely to be fair. Now, let's consider the other 3 of why they would not be a fair sample. Let's start with baseball stadium. So for a baseball stadium, most likely these people are interested in sports and sport programs. Okay, comedy club. These people are probably more interested in late night comedy. And a concert hall. Probably more interested in music or plays. The grocery store has the most diversity. Because, and we think about this, everyone eats. Okay, not everyone's a big cook, but most people do need to pick up at least one item from the grocery store about once a week. We can go ahead and just write in, since we're running out of space, everyone eats or needs food items or drink items, milk, that sort of thing. Okay, moving on, example number 4. We have Trong is trying to determine the average height of high school male students. Because he is on the basketball team, he uses the height of 14 players on the team, which are given below in inches. Okay, we're going to calculate the mean and median for this data set. We're going to round any non-integer answers to the nearest tenth. Okay, so our mean, it's again out of 14 players. I'm not going to show the work this time on the calculator, but when you add this all up and you can double check, it's 1,044. Okay, again, I need to see this step of work. Your homework should look similar to mine. Okay, your median. When we have an even set of numbers, we're going to find the middle 2 numbers. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, it is 74 and 75. We're going to add those together, divide by 2, and we get 74.5 inches for the median. Okay, is the data set above a fair sample to determine the average height of high school male students? Okay, and then we're going to explain our answer. So again, what we are going to do is we are going to analyze and interpret. Okay, so analyzing this data, we're looking for the average height of high school male students. This student, Trong, focused on the high school basketball team. Do you think that is a fair sample? And then we have to put our reason into words. Okay, we would say that this is not a fair sample. Okay. The reason it is not a fair sample, basketball players tend to be taller than the typical high school male student. Of course, not always, but if you compare the basketball student to another random, maybe group of 5 high school students, they are going to tend to be taller. Okay, and there is lots of research to back that up. So let's write that down, that basketball players tend to be taller than the typical high school student. One more thing I want to point out. Oh, we're talking about male students, so I'm going to squeeze that in there. Notice I use the word typical and not average. Okay, so we are finding averages right now, so we cannot use the average or mean, okay, because we don't really know it right now. Typical is kind of your well-rounded, random student. Okay, all right, that is it for these notes. Next time I see you, we will go ahead and finish up problem number 5. See you guys next time in class.